Hello, this is Mr. Stansbury. I'm going to take you through the notes on rules for differentiation. At the end of this, you should be able to say, I can calculate the derivative of a function using the rules of differentiation, and I can interpret the meaning of a derivative. Okay, so first thing we want to take a look at is, here's our derivative function and how it came about. Okay, so this is kind of like just kind of pause and take a look at this. You don't need to write this all down. This is just kind of where the formula for the derivative is coming forth. So and basically it's the gradient, the slope of the tangent at a general point is this here. So how they're getting to this is, let's say we've got point A and point B that are on this curve here. This distance between A and B is h, and this distance between A and B vertically, that's horizontally, vertically, is x plus h minus f of x, which is, I know, a little bit of a stretch here. How this works is this is our x plus h. So if you plug x plus h in, and then you plug in f of x right there, so you subtract those two, which basically subtracts this piece off, you're left with this length right here. That's where that's coming from. Okay, so the chord AB has a slope of, that's going to be the function of x plus h minus the function of x, this here, rise over the run, which is the x plus h minus the x right here, leaves us with the h here. Okay, so that's what this ends up with right here, and this f of x, this numerator here, stays the same. Okay, so this ends up being our formula, which I know is kind of a lot to chew on right there, but just to kind of so you know where the derivative, the slope of the tangent at a general point, where that formula is going to come from. Something else that can kind of go along, that goes right along with that, is here's our line AB, right? So here's our y distance, here's our x distance. As this gets closer and closer and closer, we've seen this this little graphic here before, but as this B gets closer and closer and closer to A, notice that this line here is getting closer and closer to the tangent line until we get all the way down right on top of A, and then that becomes the same line. Okay, and then if we go past, then that tangent line goes a little different, or the slope of the chord there. Okay, so let's cut to the good stuff. Here's the formula. The derivative of function y equals f of x is defined as f prime of x, or dy over dx. You'll see it sometimes shown as that, as the limit as h approaches 0, right? Because we're trying to get this back here. We're trying to get this h value here. We're trying to get this h as close to a as possible. So what's happening to it as it's getting closer and closer to a? Okay, as h approaches 0 of this function here. Okay, so example 7. Use first principles to find the gradient function f prime of x of f squared, f of x equals x squared. So to do this using these first principles, this is actually a section that we skipped, so I just wanted to at least introduce it to you so it wasn't completely foreign to you. Again, this is not a big important piece, because we're going to actually, there's going to be a nicer way to do all these derivatives, but again, I wanted to show you what they're talking about with this. So the function of x plus h, now we're basically in this here, f of x equals x squared. So we're going to take x plus h, we're going to take the x plus h and we're going to square it, right? Because we're basically replacing the x with the x plus h, so squared. And then we're going to subtract f of x, and we know f of x is already x squared, so minus x squared all over our h here. Okay, now what we want to do is FOIL this thing out, and we'll just cut straight to the chase. This will be x squared plus 2x h's plus an h squared, and then we have minus an x squared here all over h. This negative x squared and positive x squared will cancel out. And then what we can also do is factor an h out of both of these, what we have left here, right? So we really have let's write it as hx plus h squared all over h. We're going to factor an h out of both of these terms on the top, so we have h times 2x plus h all over h. Those can basically cancel each other out, and we're just left with this 2x plus h, right? Okay, so we have the, officially, because this is what we're doing up here at the beginning, limit as h approaches 0 of 2x plus h. So we should have all those limit of h approaches 0 all over here, but we don't need to put that in right now. So now basically h is approaching 0, so really h is going to end up disappearing. So that means our function is just going to be our 2x here. Okay? Now, if you'll remember what we did from the previous unit, previous section, when we were finding the derivatives, we were finding the tangents, the slopes of all the tangents of the function on y equals x squared. Remember, I went back afterwards. We found the equation of that line. We graphed all those points. Remember, we had that nice straight line, and we found out the equation of that line was y equals 2x. So there's our derivative function. So now we've found the derivative. Really, we've done it 3 different ways now. One with graphing, finding all the slopes, and coming up with the line. That's the equation of the line. That's the really long, hard, painful way to do it. We can do it with this technique here, which is also kind of long and painful, or we can do the nice, short, easy way, and that's what we're going to start looking into some more. Okay, that's what this is going to show us here. So these are some of the differentiation rules here. So differentiating a constant. So f of x, if we've got some number like say 7 here, the derivative, the differentiating that constant will always turn into 0. And I can show you how that works here in a little bit. Differentiating x to the n power, this is what we talked about a few sections ago when we were doing the graphing piece. This is the nice way to do the derivative right here. So we have x to the n. What you do is this n here comes out front. There it is. And then what you do is just subtract 1 power from that n. So you end up n out front, and then x to the whatever power that was, now it's going to be 1 less than that. Okay? And if you happen to have a constant times a function, you can simply just take the derivative and then still multiply it by the constant. And then there's this addition rule, and we'll take a look at that a little bit down the road. But what we want to do is we're really going to kind of focus in on this differentiating x to the n and a constant. That's going to be kind of the big business here. Okay, so if we're going to differentiate this one here, so f prime of x is going to be, remember this 2 comes out front, 2 times however many x's is there, so it's 2 times, officially it's 2 times 1 x squared, right? And then we're going to subtract 1. So when we simplify that, we have f prime of x equals 2 times 1 is 2. And then we have x to the 2 minus 1 is x to the first, or the nice simple way to write that is f of x equals 2x. Okay? And again, we talked about that in an earlier section. But I really wanted to make sure that that was making some sense here. Because this is the nice way to do the derivatives. There's many ways to do it. This is the nice way. All right, before we go to the next one, let's take a quick little comedy break.
Time in my life where I see a walker without the tennis balls on the bottom. Honestly, all the technology we have nowadays, could we please slow down production on the next iPhone and just dedicate a couple guys from Apple to work on the tennis ball, on the walker problem we have running rampant in this country?
All right, example 8. Find the derivative of this big, huge mess. Okay, and now I know that looks pretty awful here. Oops, wrong one. But that is basically this one here. You can take the derivative of each individual piece. Just take the derivative of each piece, and it's called the addition rule. Okay, so we're going to apply that to take the derivative here. So we're going to take the derivative of each one of these things and add them all together. Okay, so first one here, take the derivative of this piece here. 4 times 3 is going to give us 12. And then we're going to subtract 1 power from that, so it's 12x to the third. So the derivative of 3x to the fourth is 12x cubed. Okay, so y prime is going to equal. And now we're going to do the derivative of this one here. 3 times negative 2 is negative 6. Subtract 1 from that, and we're x squared. Okay, 2 times 5 is 10. X to the 2 minus 1 gives us to the first, so I'm just going to leave it because we don't need to put the 1 up there. And then this is x, 10x to the negative 10x to the first. 1 times negative 10 is negative 10. And now we have x to the 1 minus 1. So that turns that x into 0, so it's just negative 10. Okay? And then here's why the constant, derivative of a constant, is always 0. Because really right now this is 37x to the, there's no x's here, so it's x to the 0 power, right? 0 times 37 gives us 0, and then we don't care, if we've got 0, we don't care what the power of x is, because this whole thing just turns into 0. Okay, and so there is our derivative of that whole thing. Just take the derivative of each individual piece and add them together. Okay. Example 9 here. Find f prime of x for f of x equal to, this one here. Okay. So here's what you want to do first. Get all these x's in the denominators up to the numerator. Okay. So this is really going to be 4x squared minus 2x. And now we've got plus 3. This is x to the first on the bottom. So when it moves to the top, it's x to the negative first. Right. And then minus 2 times, it's x to the third on the top, on the bottom, so we move to the top, it turns into x to the negative third. Now take the derivatives. Okay? 2 times 4 is 8x to the first, or just leave that 1 off, right? And this is x to the first right now. 1 times negative 2 is negative 2. Subtract 1, and that's gone, so it's just 8x minus 2. And then negative 1 times 3 is negative 3x, and then we're going to subtract 1 from this 1, so it turns into x to the negative second. Okay, that can trick people the first few times they do that, but negative 1 and negative 1 is negative 2. Okay, negative 3 times negative 2 is plus 6x, and then again subtract 1, and that's x to the negative fourth. Okay, I'm fine if you to leave it like this. Probably a better answer would be 8x minus 2, minus 3, and then the x to the negative second goes back down on the bottom, x squared, and then plus 6, and then the x to the negative fourth goes back down to x to the fourth on the bottom. Okay, so then that's the derivative of this piece right here. Okay. With part B here, you want to take each one of these 3 terms on the top and divide all of them by x, and then simplify, and then away we go. Okay, so backing up to this over here, this was still our regular function right here. This right here, this is this is, say, f of x. All we did was just simplified this. And now this is f prime of x. Same idea here. This is simply going to be f of x. We're not doing any derivatives yet. We're just simplifying it. So x squared over x minus 4x over x plus 11 over x. So I took each one of these terms and divide them all by x. Okay. Now I'm going to move these x's on the bottom up to the top, right? We're going to simplify. So this is still f of x. We're still not doing any derivatives. We're getting it into shape where we can take the derivative of it. So basically this is going to be 2 minus 1. So this is going to be x to the first, right? And this x on the top and x on the bottom, those cancel out. So it's just minus 4. And then this, there's no x on the top, so we move that up to the top, plus 11x to the negative first. Now we can take the derivative. Now we'll do f prime of x. Okay, so 1 times x is 1, and then that's x to the 1 minus 1. So this is just 1 times 1. This is simply just a 1. Sorry, I said the number 1 a lot of times in there. This is a constant, remember, so this is officially x to the 0. 0 times anything is going to give us 0, so this is plus 0 for this constant here. Okay, and then negative 1 times 11 is negative 11, and then we subtract 1 from that, and that's x to the negative second. So really our better bet is f prime of x equals 1 minus 11x to the negative second, or it could be f prime of x equals 1 minus 11 over x squared. Either one of those would be just fine. Okay? Okay, we're going to call this for the first half of this rules for differentiation. We're going to do a part 2 on this and wrap it up in that one. Okay, if you have any questions on this, please feel free to ask. Thanks.